Hi again, Intermediate Algebra gang. This day we're going to look at Lesson 6.5, Graphing Linear Equations. This is something you've done for a while. We know you've done it in previous years. I would say one of the most important skills in all of mathematics to be able to graph a linear equation. So if you haven't got it up to this point, this is the time we really want you to nail down this concept. Anyway, you may have heard your teacher mention, last chapter we also did some graphing here, but our emphasis was on ordered pairs. And we looked at some practical type examples and situations where we could generate some ordered pairs in order for us to graph lines. Well, this chapter we want to really work on the slope-intercept form and really figure out how to graph lines based on that and get really, really good at that. No matter if the equation is given to you in slope-intercept form, as is this one right here we're going to look at, or if it's given to you in standard form or something else. So that's what we really want to become good at this unit. Alright, let's take a look at this equation, y equals 5/2 x minus 3. We remember that the number that's always multiplied by x when it's in this form, that is the slope, and the number that's by itself, that's that b value, that is the y-intercept. So if you can get an equation in that form, not only is it easy to graph, but it's also easy to put in your calculator and check in that way as well. Anyway, the steps to doing this is we always want to plot the y-intercept first. So that is -3. The y-intercept, remember, will always be on the y-axis, just like that. And so I'm going to plot that here as best I can at -3. I put 1 point there. And then I take a look at my slope, and I just count from that. So from that, 5/2, I'm going to go up 5. So that'll take me to +2, and then over 2 like that. And I just maybe do that another time or two. So up 5 will take me to 7, and then over 2 like that. Now the nice thing about graphing lines is you can also go down 5 and back 2. So I could be down here and here when I count that out. And then I'm going to connect these points up with an arrow on each side, because this line does go on forever and ever, and thus my graph is done. So plot the y-intercept, count the slope. What happens when we get an equation that's more in standard form like this? Well, we've been practicing this a little bit. Even last chapter we did this. Sometimes standard form works out pretty nicely to make this little chart like this. Put in 0 for x and 0 for y. So if I put in 0 for x, 2 times 0 of course is 0, that term is basically gone. -5 times what is 10? So it would be 2. So I know the point 0, 2 is on the graph. And then I put 0 in for y, same type of thing. -5 times 0, that's gone, you can cover that up. So 2 times what is -10? And -5 is my answer, so -5, 0 would be my point, and that's good enough to be able to graph, and so I can connect them up like that. Now that's one way of doing it, which is certainly fine. Let's talk about could I get a standard form equation in slope-intercept form? Well, let's see if I could do that. Again, the key thing is to solve for y, and we've been doing that in this class certainly, so you should be able to accomplish that. I'm going to first of all subtract 2x from each side, like that. So then I have -5y equals -2x minus 10. I'm going to leave my answer, or write it in that order, because I like to have that x first, just so it matches that slope-intercept form. Last step then is to divide by -5. And what my final answer ends up to be then is y equals, now -2 divided by -5 is like +2/5 x, and then -10 divided by -5 is +2. So there's my slope-intercept equation. Notice it should match up with how I graphed it on just from my standard form there. My y-intercept of 2, and if I count my slope, I'm going to go down 2 and over 5, which will take us to that point. Remember, I can go also up 2 and over 5 like this. So sure enough, I get that same line. So standard form, again, you can use this intercept method. Works fairly well, but remember the surefire way of doing these problems is to solve for y.